Good afternoon, everyone. Yes, very good afternoon, Noreen. Okay, so students, I think we are doing in our last class the circle chapter, and the exercise on that chapter was completed, isn't it? So today we'll discuss few more theorem from these chapters. Okay. So before starting the theorem, I have a question for you. Can you tell me that how many tangents can be drawn from a point outside the circle to the circle? How many tangents we can draw from there? Yes, very good. We can draw at most 2 tangents from a point which is outside the circle. So today now we are going to prove that the length of the tangents that drawn from a point outside the circle are of equal length. Okay? So let us draw a circle. Let us draw a circle. Okay, with center O, and take a point A here, which is outside the circle. Now from the point A, draw 2 tangents. One is AT and one is, suppose, AP. This is P point and this is Q point. What we have to prove? We have to prove that the length of the tangent AP and AQ will be equal to each other. We have to prove that AP and AQ are equal to each other. Okay. So how we can prove that the length of the tangents are equal to each other? So what is given? Given here that O is the circle, O is the center of this circle, A is a point outside the circle, and from that point we have drawn, there are 2 tangents are given. One is AP and one is OQ. What we have to prove? We have to prove that the length of these 2 tangents are equal to each other. Okay. Now there is a construction. Construction is join P2O and OQ. We are joining AP, we are joining OP and OQ, and also AO. Okay. Now can you tell me what will be the value of angle OQA and OPA? What will be the value of angle OQA and OPA? 90 degree. Yes, they will be 90 degree. Why they are 90 degree? Because in previous class we have learned a theorem that the tangent and the radius through the tangents are perpendicular to each other. So this is the tangent and this is the radius through the tangent. So this angle must be 90 degree. Also this angle must be 90 degree. Okay. Now do one thing. Compare these 2 triangles, triangle APO and the triangle AQO. So if I compare the triangle, in the triangle APO and the triangle AQO, if I compare them, so first condition is angle P and angle Q are equal to each other. Means angle APO is equal to angle AQO. Why they are equal? Because both the angles are equal to 90 degrees. Second condition. The second condition is, look, OA. OA is the side of the triangle AOP Also OA is the side of the triangle AOP. AQ means OA is a common side. OA is a common side. Okay, and number three condition is, what is OP and what is OQ? Both are the radius of the circle, and we know that the radius of same circle are all equal. So we can write OP equal to OQ because they are the radius of the circle. Radius of the circle. Now from these three conditions, we can say that the triangle APO is congruent to triangle AQO. Can you tell me by which condition the triangles are congruent to each other? By which criteria? Yes, very good. This is right angle, hypotenuse, side. By RHS criteria, we can say that the triangles are congruent to each other. Now, whenever the triangles are congruent to each other, we can say that their corresponding parts are also equal, isn't it? So, we can write that AQ will be equal to AP. AP is equal to AQ, and hence the proof. Not only that, we can also write that this angle AOP is equal to AOQ. AOP is equal to angle AOQ, means the tangents makes equal angle at the center, and we can write these two angles are equal. Okay, these two angles are equal. So, but here we have to just prove this, that the length of the tangent are equal to each other. Okay, now students, you tell me, have you understood the theorem, or did, if you want, I can repeat the theorem once again. Now tell me, what do you want? If you have understood, then we'll go to the exercise problem. Otherwise, if you have any confusion, we can repeat the theorem again. Tell me what to do. Shall I go to exercise problem? Or have you understood the theorem? This is a very simple theorem. Have you understood? Okay, so let's go to the exercise 10.2. Okay, so the first question is, from the point Q, the length of the tangent to a circle is 24 centimeter, and distance of Q from the center is 25 centimeter. Find the radius of the circle. Okay, so let's draw a circle. Okay, so this is our circle with center O. Okay, and let us consider a point Q here. From here, the length of tangent is equal to 25 centimeter. The length of the tangent is 24 centimeter. And distance of this point from the center is 25 centimeter. We have to find what is the radius of the circle. What is the radius of the circle? Let the point of contact as P. So we have to find what is the length of OP. Now we know that the tangent and the radius all through the tangents are 90 degrees. So that means the triangle POQ is a right angle triangle. So if I consider the right angle triangle POQ And if you apply the Pythagoras theorem here, so applying Pythagoras theorem, we have hypotenuse OQ square is equal to perpendicular OP square plus base PQ square. That means what is the value of OP square? That is equal to OQ square minus PQ square. That means OP square is equal to 25 square minus 24 square. That means what will be the value of OP? Do the calculation and tell me the answer. What will be the value of OP? Quickly tell me the value of OP. I think you know the value of 25 square and 24 square. So subtract it. Subtract them. Yes, very good. Shomodip, very good. The answer will be 7. OP will be 7. That means the radius of the circle is equal to 7 centimeters. Very good. Okay. So now let's see the next question. Question number 2. Question number 2 is in the figure 10.11. Okay, one circle is drawn here. So draw a circle. Okay. So this is the circle with center O, and PT and PQ are two tangents. This is our PQ, so this is T point, and this is another tangent as PT. Angle POQ equal to 110. POQ. This angle is equal to 110 degree. We have to find what is the measurement of angle PTQ. What is the value of this angle? Okay. Now look. What is TQ? TQ is the tangent. And what is OQ? OQ is the radius through the tangent. So we know a theorem that the tangent and the radius through the tangent are perpendicular to each other. So this angle must be 90 degree. This angle must be 90 degree. Similarly, the angle P will be 90 degree. Now if we consider the quadrilaterals POQT, if we consider the quadrilateral POQT, and if we apply the angle sum property, so what is the angle sum property of a quadrilateral? It says that the sum of all interior angles of a quadrilateral is equal to what? Can you tell me? What is the sum of all interior angle of a quadrilateral? Yes, very good, 360 degree. So if I apply the angle sum property, we have angle P plus angle O plus angle Q plus angle T will be equal to 360 degree. That means what is the value of angle P? That is 90 degree. Value of angle O we don't know. Value of angle Q is again 90 degree plus value of angle T we don't know, that is equal to 360 degree. That means, sorry, angle O is 110, we know the value, 110 degree. So from here, angle T will be 360 degree minus 90 degree plus 110 degree plus again 90 degree. Now do the calculation. That means angle T is equal to 360 degree minus, that is equal to 200 and I think 90 degree. Now do the calculation. Subtract 290 from 360. So that will be, I think 70 degree. Yes, 70 degree. So that means angle T is equal to 70 degrees. So this is the answer. Angle T is equal to 70 degrees. Okay, students, do you have any problem in this question? No. Okay, so then go to the next question, question number 3. If the tangent PA and PB from a point P to the circle with center O are inclined each other at an angle 80 degree, then angle POA is equal to. Okay. So draw a circle. This is our circle, and let us consider a point here. The name of the point is P. So from P point, draw two tangents. One is P and one is PB. And this is the center. It is given that angle, so that if the tangent P and PB from the center P to a circle with center O are inclined each other at an angle 80 degree. This angle is given as 80 degree. We have to find what is the measurement of this angle. AOB. What is the measurement of this angle? Now look, we know this angle is 90 degree. This angle is 90 degree. Now apply the angle sum property in the quadrilaterals AOBP. So in the quadrilateral AOBP, if we apply the angle sum property, we have angle A plus angle P plus angle B plus angle O, that is equal to 360. So from here put the value, that means angle A equal to 90 degree, angle P equal to 80 degree, angle B equal to again 90 degree, angle C, angle O, we don't know the value of angle O, that is equal to 360 degree. So from here if I calculate, angle O will be equal to 100 degree. So angle O is equal to 100 degree. Actually P and O are supplementary angle. If this is 80 degree, so this angle will be 180 minus 80 degree. So the answer is 100 degree. 100 degree is the answer. Okay, now the next question, prove that the length of the tangent drawn at the end of a diameter of a circle are parallel to each other. Prove that the tangents drawn at the ends of a diameter are parallel to each other. So let's draw a circle. Okay, so this is the circle with center O. Take a diameter. Diameter means a line which divides the circle into equal parts. So this is the diameter, and A and B are the end of the diameter. We are drawing two tangents. One is at the point A and one is at the point B. What do we have to prove? We have to prove that these two lines are parallel to each other. Okay, so this is a P point and this is Q line. So AP and BQ are parallel to each other. We have to prove. AP is parallel to BQ. AQ is parallel to a BQ. Now how we can prove that the lines are parallel to each other? Now look one thing. What is, starting from here, what is PA? PA is the tangent. And what is OA? OA is the radius through the point of contact. So we know that the tangent and the radius through the tangents are perpendicular to each other. So this angle is 90 degree. By same reason, we can say that this angle is also 90 degree. Okay. Now, suppose there are two lines and there is one transversal. So can you tell me what type of angle these two are, what type of angle? This angle and this angle. What we call the angles? The angle are called, quick. Interior angle on the same side of the transversal. Interior angle on the same. In short, they are called co-interior angle. Okay, Shomodeep and Nori, they are called co-interior angle. And if the sum of the co-interior angle is 180 degree, means suppose this is x degree and this is y degree. If the sum of these two co-interior angle is 180 degree, so we can say that the lines are parallel to each other. If the sum of two co-interior angle are equal to 180 degree, so we can say that the lines are parallel to each other. Now look, here this angle and this angle are co-interior angle, and if I add these two angles, so the result will be 180 degree. So we can say that the line AP and the line BQ are parallel to each other. Okay, this is the way we have to prove the theorem. Okay, now in detailsly we are doing the theorem, proving the theorem. Now here PA is the tangent, and AO is the radius through the tangent. That means angle PAO is equal to 90 degree. By similar reason, we can say that similarly angle QBO is equal to 90 degree. Now just add these two angles, angle PAO plus angle QBO, which is equal to 90 degree plus 90 degree, that is 180 degree. But angle PAO and angle QBO are co-interior angles, and their sum is equal to 180 degree. So we can say that AP is parallel to BQ. That means AP and BQ are parallel to each other. That means the tangents at the end point of the diameter are parallel to each other. Okay, and hence the theorem proved. Now tell me, have you understood? Have you understood? Okay, so very good. So up to this today, we have to stop over here. In my next class, we'll start from question number 5, and we'll hope within 2 class we can solve this exercise. Okay. So up to my next class. Bye bye.